Imagine switching on a spaceship engine so powerful it pushes you to the speed of light. Not close to it, not almost, the actual cosmic speed limit. You aim into the darkness, leave Earth behind, leave the Sun behind, leave the Milky Way behind, and you keep going forever. And somehow, after all that, you might still see absolutely nothing. No stars rushing past the window, no glowing galaxies, no beautiful cosmic ocean full of light, just black. That sounds impossible, right? If the universe is full of stars, then surely, if you travel far enough, you must eventually hit something, or at least see something. But this is where the universe gets strange, because space is not just big. Space is expanding. Light has limits. Time has limits. And there are regions of the cosmos that may already be forever unreachable, even if we had the fastest ship physics allows. So today, let's talk about one of the most unsettling ideas in modern cosmology. We could travel at the speed of light forever and still see nothing. To understand why, we need to start with a simple question. Why is the night sky dark? It sounds like a childish question, but for centuries it bothered some of the smartest people on Earth. If the universe is infinite, and if it has an infinite number of stars, then every direction you look should eventually end on the surface of a star. The night sky should not be black. It should be blazing white, as bright as the surface of the sun. This is known as Olber's paradox. But the sky is dark because the universe is not just an endless, frozen stage, packed with eternal stars. The universe has a history. It had a beginning, at least in the form we know. It is about 13.8 billion years old. That means light has only had a limited amount of time to travel. When you look into space, you are not just looking across distance. You are looking back in time. The moon is about 1 light second away. The sun is about 8 light minutes away. The nearest stars are years away. Some galaxies are millions or billions of light years away. So, when you look at a distant galaxy, you are seeing it as it was when its light began the journey toward you. Some of the galaxies we observe are so distant that their light started traveling before Earth even existed. But here comes the first twist. The observable universe is not the whole universe. It is only the part of the universe whose light has had enough time to reach us since the beginning of cosmic history. You can think of it like standing in a fog at night with a flashlight. You don't see everything that exists. You only see what the light can reveal. The observable universe is our cosmic bubble. Its radius is about 46 billion light years. That number can sound confusing because the universe is only 13.8 billion years old. How can we see something 46 billion light years away? Because space itself has expanded while the light was traveling. The light from the most distant regions has been moving toward us for almost the entire age of the universe. But during that time, the distance between us and the place it came from kept stretching. This matters because expansion is not like galaxies flying through space from a central explosion. There is no center where the Big Bang happened. Space itself is growing. The distances between galaxy clusters are increasing because the fabric of the universe is stretching. Now, imagine ants walking on the surface of a balloon as it inflates. The ants can move across the balloon, but the surface itself is expanding beneath them. If the balloon expands fast enough, 2 ants can walk toward each other and still get farther apart. That is basically what happens on cosmic scales. Light always moves through space at the speed of light. But if the space between 2 places is expanding fast enough, light can struggle to make progress. In some cases, Light emitted from a distant galaxy today will never reach us, not because it is slow, but because the space it must cross is expanding too quickly. This leads to a disturbing truth. There are galaxies we can see right now whose current light will never reach us. We see their ancient past, but we will never see what they look like today. Their present is already lost to us, and in the far future, the universe will become much lonelier. Right now, telescopes can detect billions of galaxies. The universe looks crowded, rich, alive with structure. But as cosmic expansion continues, distant galaxies will drift beyond our horizon. Their light will become stretched, redshifted, dimmed, and eventually invisible. Future astronomers, if they exist trillions of years from now, may look up and see almost nothing beyond their own galaxy group. The evidence for the Big Bang, the cosmic web, and the wider universe may be hidden from them forever. They might believe their island of stars is all that exists. Now, let's return to our impossible spaceship. Suppose you could travel at the speed of light. In reality, anything with mass cannot reach light speed. It would require infinite energy. But let's imagine a magical ship that can do it anyway. You point it toward a region of deep space and go. Wouldn't you eventually reach another galaxy? Maybe. If you choose carefully, and if the galaxy is gravitationally bound to us, or close enough, yes. But if your target is far enough away, expansion changes the game. Even at light speed, there are regions you can never reach. The destination is not simply sitting there waiting. The distance itself is growing. And if you travel into the wrong kind of cosmic emptiness, you may cross unimaginable distances without encountering anything at all. This is because the universe is not evenly filled with matter. It has structure. Galaxies gather into groups, clusters, and superclusters. Between them are giant voids, enormous regions where there are very few galaxies. These voids are not completely empty, but they are emptier than anything our brains are built to understand. A cosmic void can span hundreds of millions of light years. If the Milky Way were inside one of the emptiest regions, the night sky might look very different. There might be far fewer bright galaxies visible from Earth, and these voids are growing. Gravity pulls matter into dense regions, while expansion stretches the gaps between them. Over time, the universe becomes more web-like. Matter clumps into filaments and clusters, while the spaces between them become larger and emptier. So, if you left the Milky Way and headed into a cosmic void, the journey would be almost impossible to imagine, and you could travel for millions of years at light speed and see little more than faint smudges behind you and ahead of you. But the title says forever. Could you really travel forever and still see nothing? Here, we need to talk about the future of the universe. The universe is not only expanding, its expansion appears to be accelerating. The cause is what we call dark energy, a name that sounds dramatic, but mostly means we don't fully know what it is. It behaves like a property of space itself, pushing distant regions apart faster and faster over time. If dark energy stays constant, then the far future becomes extremely dark. Galaxies outside our local gravitationally bound group will slip beyond reach. Their light will fade. The cosmic microwave background, the afterglow of the early universe, will stretch to wavelengths so long and cold that it becomes practically undetectable. Stars will burn out. New star formation will slow as gas is used up or locked away. Massive stars die quickly. Smaller stars can last for trillions of years, but even they eventually fade. White dwarfs cool. Neutron stars go quiet. Black holes remain for absurd lengths of time. But even black holes may eventually evaporate through Hawking radiation. The future universe may become a place of near-total darkness. In that era, a traveler moving through space might pass through regions where there are no shining stars, no visible galaxies, no glowing nebulae, no obvious landmarks, just particles, radiation too faint to notice, and distances so large that numbers begin to lose meaning. But even today, the idea contains a deeper point. When seeing something depends on light reaching you. If an object exists beyond your cosmic horizon, it may be real, but it is not observable. No telescope can reveal it. No signal from it can arrive. No message can be exchanged. It is not hidden behind dust or blocked by bad equipment. It is separated from us by the structure of space-time. That is a hard idea to accept, because we are used to thinking of the universe as one shared place. If something exists, we imagine it is just far away. With a better engine or a better telescope, we think we could get there. Cosmology says not always. Some distances are not just difficult, they are permanently disconnected. This is one of the reasons the speed of light is so important. It is not just the speed of photons, it is the speed of causality. It is the fastest speed at which information, influence, or change can travel. If two regions of space are moving apart in such a way that light can never cross the gap, then they are outside each other's causal future. One region cannot affect the other. For all practical purposes, they become separate universes, not separate in the science fiction sense, separate in the physical sense. No contact, no observation, no shared future. And yet, from our point of view, the universe still looks full. That's because we are seeing old light. The sky is like a cosmic archive. It contains messages from galaxies as they were long ago. Some of those galaxies have changed beyond recognition. Some have merged. Some have exhausted their star formation. Some are now so far away that their modern light will never arrive. The night sky is not a live broadcast, it is a memory. There's something beautiful and unsettling about that. Every telescope image is both discovery and farewell. We are seeing things that may already be gone from our reachable universe. Now, imagine traveling at light speed through that archive. As you move, your view changes. Light from some directions becomes blue-shifted, compressed to higher energies. Light behind you becomes red-shifted, stretched, and faded. The universe would not look like a normal star field. Relativity would distort your perception. The sky would warp. Directions would compress. Time itself would behave differently for you than for those you left behind. At light speed exactly, ordinary ideas about time break down. For a photon, if we can even speak that way, no time passes between emission and absorption. A photon from a distant star does not experience a long journey, but for observers watching it, billions of years can pass. So, our imaginary traveler is already beyond real physics. Still, the thought experiment helps reveal the main point. Speed alone does not guarantee access. The universe is not a static map. It is a dynamic space-time with horizons. This is why forever is such a strange word in cosmology. Forever does not mean you eventually see everything. Forever can mean you continue through an expanding darkness while more and more of reality moves beyond contact. Forever can mean infinite time inside a shrinking island of what is visible. And this brings us to one of the biggest unknowns. What lies beyond the observable universe? We don't know. It may be more of the same. More galaxies, more cosmic web, more vast emptiness. It may be infinite. It may be finite but unbounded, like the surface of a sphere, but in higher dimensions. It may contain regions forever beyond our horizon, with histories we will never observe. The important thing is that observable universe is not a wall. If you could magically pause expansion and travel far enough, there would likely be more space beyond what we see. But because expansion and light speed matter, those regions may be inaccessible in practice. So, when we say we could travel at the speed of light forever and still see nothing, we are not saying the universe is empty everywhere. We are saying emptiness can dominate your experience. We are saying that horizons can hide reality forever. We are saying that the universe is under no obligation to reveal itself, no matter how fast we chase it. And maybe that is what makes astronomy so powerful. We are tiny, fragile observers on one planet, around one ordinary star, in one galaxy among billions. And yet, during this brief cosmic era, the universe is still visible to us. The galaxies have not all vanished beyond the horizon. The cosmic background is still detectable. The evidence is still here. We live at a time when the universe can still tell its story, but it will not tell it forever. One day, the sky may go quiet. The distant galaxies may fade into darkness. The great cosmic clues may stretch away until they are impossible to detect. Future civilizations may look out and see almost nothing, not because nothing exists, but because the universe has carried the evidence away. That is the strange tragedy of cosmic expansion. The universe can be full and still become invisible. It can contain endless structure and still appear empty. It can be larger than imagination and still leave a traveler surrounded by darkness. So, the next time you look at the night sky, remember this. The darkness is not simple emptiness. It is distance, time, expansion, and history, all layered together. It is the edge of what can reach us. It is the shadow of everything we may never know. And the stars we do see are not just lights. They are proof that, for now, the universe is still close enough to speak. If this journey through cosmic darkness made you think, like the video, subscribe to the channel, and tell me in the comments, would you rather explore the farthest edge of the observable universe or travel into the deepest cosmic void and find out what true emptiness feels like?